thought on the idea about this talk is about how should I, as a Java developer, get started with these container technologies. There's something called Docker. I don't know sure what it is, and how can I take my Java code and run it on that, and just on my laptop. You know, no fancy cloud providers and whatnot. So this is the talk for you guys. I've been working with for Red Hat for many years. Most famous for working on Apache Camel, but for the last couple of years, I've been working with cloud technologies and containers, such as Fabricate and Kubernetes and Docker and whatnot. And when we talk about containers, then there's this whale logo that has made all that kind of famous. I'm pretty sure most of you guys have heard about Docker. So what Docker has done is to make using Linux containers much more easier and approachable for developers and operations guys. But this product has taken off like no other products in the history, more or less. So it's very popular. A lot of people are approaching Docker and using Docker and building other things around Docker. So Apache Mesos has adapted in Docker, so you can run Docker containers on that platform. There's CoreOS has a platform, Cloud Foundry, Red Hat OpenShift, and then there's this logo down here, which is what I'm going to talk about today, Kubernetes, and a bit about Fabricate, which is an upstream open source product that we work on for container technologies. So what we have down here on the bottom is the Docker as the container virtualization, but Docker by itself is intended to run a Docker Linux container process on a single host. But when you need something to run in a cluster, then you typically need something above that. You need an orchestration engine, an orchestration platform, and that's where something like Kubernetes come into the game, to be able to take Docker image and orchestrate and run them on a cluster. Kubernetes is very operation focused. It's not so as much developer focused, and it lacks a number of features. And that's where you can say there's an opportunity for on top of that. And Red Hat OpenShift has done that. For example, Kubernetes has no notion of security. There's no user management. There's no tooling for developers. There's no build pipeline and kind of things that an everyday enterprise company needs. Google Kubernetes was built by Google, and it's that's the Google picture, and that's how it started out as. Then there is another product I talked about just briefly, Fabricate. What is that? That's a very good question. Is it something on top of OpenShift, or is it on top of Kubernetes, or what is it? Well, I like to picture Fabricate sort of on the side. So Fabricate provides a set of microservices and tools and whatnot to each of those. So we have some tools for being able to build Docker images and run them and stop them and whatnot on a laptop. We have a web console for Kubernetes. We have tools to build some what is called a Kubernetes manifest files, which you need to use for deploying into the Kubernetes platform or scale things up and down. We have building tools for OpenShift and whatnot. So there's a bit for everything. Okay, so I talked about this one, Kubernetes, and already said is Google Kubernetes. So even though Docker has made containers quite famous, it's not a new technology that they invented or a new technology that just got on the scene. It's actually something that has been around for decades. And Google has been using Linux containers for many, many years, more than 10 years. And they have an internal cluster management system for that. It's called Borg. And what Google wanted to do was to make a new version of Borg, but of course better, because they have over the time learned a lot of things about running a huge number of Linux containers. And they want to do a new version of Borg, and they were actually allowed to do that in the open source. So they actually pushed that out on GitHub, on Kubernetes, a couple of years ago, and that product, just like Docker, has taken off like no other. It's a very popular product as well. And other companies besides Google are contributing and work on that. For example, Red Hat, CoreOS, and HP and IBM, and also individuals. So it's a true community product. Now, one of the awesome thing about Kubernetes is that it's based on the idea of desired state or state. So the idea is that I tell the platform, I want 5 instances of that application running, I want 10 of that, and between 5 and 7 of those. And you can also specify a restriction on the resource, saying this one is allowed to use so much CPU time, so much memory, and so much disk, and so on and so on. And then you leave it up to the platform to figure out how to run these applications or containers on which node in the cluster. You don't specify it should only run on this one. You just tell it this is the state I want, and then the cluster itself or Kubernetes figure out how to do that. And it does this, it keeps monitoring what is the current state and what is the desired state. What did you tell me it should be? And if it's the same, it's a line up, then yes, everything is cool. But now suppose that a node, a rack of node, or just crashes or something, and then a lot of containers dies, and then the current state goes down. Then the container figures out, oh, there's something going on here, there's a gap here. So it needs to figure out, okay, I need to run 2 more instances of that one and 5 more of that one, and do it on the current node that works. And the platform figures out how to do that. And by that you get this notion of self-healing in the platform. And also very awesome thing that Kubernetes has made is that it's very easy to do service. So an application can easily expose a service, and a client can easily look up and discover that service and use it. You're going to see that. So the architectural diagram of Kubernetes is something like this. So you have a highly available master, and that master controls a number of nodes. Now the slide says minion. Minion was the old name Kubernetes used for a node. Now today it's called a Kubernetes node. So on the nodes you run Docker, where you run your application inside a Docker container. But those Docker containers run inside something called a pod. And we're going to see that in a moment what that is. So when using Kubernetes, what are the key concepts you should know? Well, there are the nodes. Those are either the physical or the virtual machines where you run your pods. Okay, so pod, what is that? A pod is actually just a collection of Docker containers. So a pod can contain 1 Docker container. That is very typical. That's 1 container to run your application. But you can also have 2 or 3 or 4, and they are co-located together. We're going to talk a bit more about pod in a second. Another concept is called a replication controller. That is the guy that controls the pods. That's the guy that can figure out how to spin up more pods or scale them down and so on. Then there's the service, which is what you use to application to communicate with each other, or to communicate with the application in the cluster over the network. Then in Kubernetes you can assign labels to anything. It's sort of like a Dino sticker. A guy you can put a label to anything, like a crazy little kid that put labels everywhere, right? So a label is just a key value pair as a human logical meaning for you guys. So for example, you can create a label called application equal camel or something. And then you can associate labels to anything, to all your parts that has camel inside. And then you can use you can query the Kubernetes API registry to find all running parts that has these labels, and the labels equal what. And you can have multiple labels in the query. And then you can find your stuff easily. And you can do that easily everywhere. And there's also something called namespaces. So in Kubernetes, you can sort of have like a virtual cluster inside the physical cluster. So all your pods and service and replication controller and whatnot in the same namespace, they can see each other. But you can have another namespace that is totally separate from each other. But one of the most important top concept is the pod. So what is a pod in Kubernetes? Again, it was a group of containers that run together on the same node. The idea is that a pod has a unique IP address. So all these containers run in the same network space, and they can talk to each other using the local host. And they can also share the same volumes, the file system. But the good thing about having unique IP address on a pod is that you can run a container inside that pod, and you can assign any port number you want to use for that container. So if that container is Apache Tomcat or Spring Boot or something, that will typically use port 8080 for HTTP, and that's free to choose. Then you can run another pod on the same physical node that also has Apache Tomcat or Spring Boot, and it can also use port 8080 because it has its own IP address, so there's no port classes between your pods. And you can use static port numbers. That's really awesome about Kubernetes. Replication Controller, that's the guy that, that's the nanny of the pod. So that's the guy that figures out, okay, you told me to have 5 instances of this application, then I start 5 pods. And if there's only 4 sometime, then I start a new one. Or maybe a pod dies, I try to restart it and so on. So that's the guy that does all that. Then there is the service. So now step back aside. So you build an application, you package that as a Docker image, and you run that as a Docker container in a pod in the cluster in Kubernetes. Now, when you run that container, it runs on a pod on a node, but you actually don't know which node it runs actually. It can be in this node, it can be that node. If this pod dies, it can run here and so on. So your pod can actually move around. And when it moves around, it gets a new IP address. So how can I call your application in the pod if your IP address changes all the time? Well, how should I do that? Should I look up some sort of registry and find where are all the running pods with the application, and maybe there's 1 or 2 pods, and I pick one and I call you, and when I start to call you, you die, and then you fail? No, the idea with Kubernetes is that you can use a service for that. So the awesome thing about the Kubernetes service is that it's also an IP and a port number, but it stays constant for the entire lifecycle of that service. So when you have the IP and the port number for the service, you can use it all the time to call it. It doesn't matter if the pod dies and it starts over here, it's the same IP and port number to call the service from me as a client. I only need to know it one time. And it's also very good for the DNS caching and whatnot, because the IP stays the same forever. That's freaking awesome. Yeah. Sorry?
What is service? Is it a DNS like?
A service in Kubernetes means a network connection to some application where you can call over the network. So it depends on the application what the service actually means. So it could be HTTP service, it could be JMS, it could be Kafka, it could be something. But from Kubernetes point of view, it's just a socket connection over a network. Whatever is on the other side doesn't matter. So if you want to explain what Kubernetes is or better understand it, there's actually a very good cartoon video, and don't laugh about it. So there was this guy that was really excited about his work and talking a bit about to his family what he's doing, and then his son say, "Dad, what is it actually?" And he started to use technical terms, and then of course that's really hard to explain. So he created a cartoon that a really good explanation what it is, but it's also very good for us to view it. So another guy, a robot that juggles with containers, the Fabricate guy. So what is that? So Fabricate is an upstream community project that a bunch of us works on. It's on GitHub, it's Apache license, free to use, whatnot, love contributions and so on. So what we do in the Fabricate thing is to add additional microservice and toolings and whatnot to the container platform on Kubernetes. So we have, a web console, which we're going to see a bit, and you're going to also have a solution for doing centralized logging, where we can use Elasticsearch and Kibana, and you can also get centralized metrics, to capture CPU and I/O and whatnot, and see that in a nice dashboard using Grafana. There's a continuous delivery pipeline solution using Jenkins pipeline, where, for example, you can have like a pipeline that racks on a Git commit, and then it checks out the source code, build it, and run some unit tests, and if that passes, it creates a temporary, moves to the next stage, and the next stage might be an integration test where it actually creates a temporary namespace in Kubernetes, deploy some pods that do some integration testing with each other, and if that all goes down, then it passes and it terminates all that temporary namespace to close down all these resources as if it's never been there, and then it might wait for human approval to continue to the next one, and when you click a button, a send an email or something, it goes to the next one. You might deploy on a pre-production environment. It does that in a controlled fashion using rolling upgrade. I'm not going to show anything about that today because we start from the basic as a Java developer, just saying it's there. Jenkins pipeline is really awesome, and there's some videos and whatnot doing that. I'm involved with something called iPaaS, Integration Platform as a Service, where we are working on some more Camel tooling, but for the web, so you can sort of like have a web developer, or let's say a less experienced Java developer, or less experienced developer, do some lightweight integration where you might have some pre-configured Camel component, and you can set them up, and they just fill out a few details and link them together. Okay, so the part I'm going to talk more about is the tooling here. So tooling for Java developers, how to build application and run it on the cluster. So let's go fun and have a little demo. This is where everything can go wrong. So as a Java developer, I have some Java code, and I wish I had some coffee, right? So we have to stick with Java code. And there's this new thing with containers, and how do I get my stuff inside that container and run it? That's a good question. So let's get going. So let's build something we can run as a container. And there's a nice camel here, and it's a Danish camel, it's a Lego camel. So let's build something with that. I put the source code on my GitHub account. You can find it here, Claus fabricate hello. So let's build a very simple service, a hello service. So we have an application that exposes service and a client that can call the service. And you call it with something, and the client will send a message back. And because it's a clustered world, so we use the host name as part of the response, just to see that it can run on different hosts. And we implement using two different popular, or one more popular than the other, Java technologies, Spring Boot and WildFly Swarm. And we use HTTP for the service. And I'm too much biased with Camel, so I put Camel in both of them. Of course, you don't have to. You don't have to use Camel at all. You can just use Java or Node or whatever, but use Camel. So in Camel lingo, it will be something on a client. We don't want to do something ourselves, so we just use a timer, call an HTTP endpoint, and log it. On the server side, we run in WildFly Swarm. We can use the awesome Undertow HTTP engine and do a message transformation. And to create the client, I use Spring website. They have a Spring IO website where you can choose your dependencies, and there's a camel down here. Yes, awesome. And we can create the project. And there's some code here. We're going to create the camera out with a timer, call the HTTP endpoint, and log it. I'm just going to do it in a moment. But I just want to talk about the server side. The server side, build it here, but you can do the same on WildFly Swarm. It also have like a start page. It's called a generator. And you can type in the group ID and the artifact ID on Maven, and then choose your dependencies. And down here, there's some Camel dependencies. I've chosen CDI and Undertow. So the server-side code, you can, so to speak, that's where we're using Undertow, or to expose the service on 8080/hello. And then we're going to use a Java bean using CDI that's been injected. I'm going to call then from Undertow and do a bean. Okay, and the bean is just the standard CDI bean with a singleton or something, and then one method saying say hello, and they say from says hello from, and then we have a little Java class to get the host name. Okay, and now we can build that and run it. So on this one, I already filled out that and clicked the button here to get the Camel application, the Spring Boot application. Then I have unzipped it, the zip file in this directory, and then I open the source code inside IDEA. That's where I'm now, okay? So now I'm going to do something where your boss covers the eyes and ears. I'm going to delete all the unit tests. So no more testing, everything works. And let's create a camel route. Now, if you're familiar with IDEA, then I'm running this in presentation mode. That's why it looks a bit funny. Then route builder, and then implement the configure method, and from timer foo period equals 2 seconds, and then want to call the endpoint, I'm going to use the netty endpoint as for HTTP, localhost 8080, and then I'm going to log the message body. More or less it. And then with Spring Boot to being picked up by Spring Boot, you need to add this annotation called component. This is Spring Boot 1. And because I'm using the netty HTTP component as the HTTP, I need to add that as a dependency. So I go to my POM file, and I find here, choose Camel netty for HTTP, and that's it. Okay, so now I could build it and run it, but let's move on and to the slides. But now I built some local. I wanted to take that code and run it as a container. So I need to build a Docker image. So how do I take my code to build a Docker image? That is the question. You can use a Maven plugin to do that. That can build your Maven product as a Docker image, okay? And we have one from the Fabricate Maven plugin. And if you are in Sweden, they have Spotify as the company, and Spotify also created a Maven plugin, and there's a few others. So you have a number of choices, but that's a good question. Yeah, yeah. Of contribution. So the Fabricate plugin is you just need to add this plugin, and then it can sort of auto-configure itself. But if you really need, then there's additional configuration you can set to it. Okay, so I add that to my project, but I can also just type this long command on the shell, and it can add it itself. Okay, and when I do that, it adds this one to the POM with some additional execution to make it easier to run it, and I can build it. So okay, let's try that. So up here, I type this Maven IO Fabricate Maven plugin colon the version number colon setup, and when I do that, it should add itself to your Maven project. If I go to the POM file here on Spring Boot, you can see it's been added itself. Okay. Now I should be able to type Maven package to package the Java code and Fabricate colon build. Type it here. I'm just gonna take it up on the top of the screen. And if you've been using Docker before to build a Docker image, then you can see sometimes it will download the Docker base image. This is like the Docker version of a Maven repository, so it's also download the internet, so to speak. And then you see some progress bar going on. And you'll see the same here on the Fabricate plugin because it's used Docker. But I have already pre-downloaded my base image, so it shouldn't be too slow. Let's see if I forgot to set the environment. Probably. Yeah. If this guy is slow, then you forgot to do something. Then I forgot to if Docker. So I'm running a local Kubernetes cluster using Minishift, but you can also use something called Minikube. They are, more or less the same. But Minishift, you can need to set up your command line for Docker and Kubernetes. And Minishift has a Docker env method that gives you this eval here. You run this one, and then you set up your shell with all these exports. And now I should be able to build this one. Let's try run it again. And this is something that we are going to detect ourselves and improve in the future version of the plugin. Now it continues, and now it goes down here to build the Docker build. It detected it was a Spring Boot application, so it doesn't default Spring Boot settings. And now if I do a Docker image, which is a Docker command where you can look at all your local repository, what image you have. And the name of this product is called foo/client2. So when I download from Spring Boot and create the application, I call it client2. And the reason for that is because I have built the client beforehand as a good citizen, try to demo it locally to see if that worked, and then we use the second version. So this is a new one, 10 seconds ago, right? So now I have a Docker image, and I can do the same for the WildFly Swarm, which I have done. But I need to run it on a Kubernetes cluster. How do I do that? So that is where we go next. So we have our Docker image from the client and the WildFly Swarm application, and we should be ready to go, right? Everything is good. This is where you can win a prize. So if I run my application in a cluster, and I want to call your service, and I call you using localhost 8080, will that work?
Didn't you just say it had its own IP address? So
Correct.
localhost?
Exactly. So it's the static versus dynamic platform. So the applications the Hello World server is running, in IP address somewhere. I don't know, but I need to know that. So this is where we need to change something in the client, and we need to use a Kubernetes service as a client, and the application over here needs to expose it as a Kubernetes service. So there's something from the server side and also something for the client side. Let's take a look at that. So again, a Kubernetes service is what we use as a network abstraction to call a service running on a port somewhere that is dynamic, but the service IP and port number are fixed. That is a good thing. And pay attention, this is sort of what happens under the hood when you deploy something in Kubernetes with a service. So we deploy this one in Kubernetes with the service, then that service is deployed in register inside Kubernetes master registry, and those service changes are propagated out to all existing running nodes, which has a little kube proxy running. And this kube proxy therefore is aware of all the servers where they're running on which nodes. And then when the client wants to call the service with this IP and port number, it thinks it calls some physical box somewhere. It doesn't. This kube proxy steals it, and then it knows, okay, you want to call this service. I know this port and this port has the service, so I choose this one, and then it calls that for you. So this guy is doing the interception. This is the guy that steals it for you. But as an end user, I don't need to know that. I only need to know, okay, I need to call a service, and for that service, I need the IP and the port number. So I call the service just normal socket, whatever it is, IP and port number. That's it. Doesn't matter where the service is actually running and if it fails over and whatnot. Okay, so how do we declare the service on the server side, so to speak? How does the WildFly application declare the service? And the Maven Fabric plugin generates the service for you automatically, where it gives you the Maven artifact ID as the name of the service, and then it generates the port number as the 8080. This is the service port number. And this target port, that is the port number that you use inside the container. So you need a port mapping. So inside the container, that is the port number that WildFly Swarm uses and Tomcat uses and Spring Boot. Those are typically 8080. But outside, you can free to choose whatever you want. You don't have to use 8080. If you're a bit clever, you might want to use 80. Then it's easy for HTTP to call it. But you can choose any number you want. So I was a bit of just to demonstrate that. So I'm choosing 8181 as the port number, and I'm giving the name the service called hello. So I have put that information down, and what you see here on the slide is actually a Kubernetes manifest file to define a service that are using the YAML description. You can also use JSON. So this is not Fabricate specific, not Camel specific, it's Kubernetes stuff, standard Kubernetes stuff. Okay, so now we have that on the server side. Then on the client side, how does me as a client look up that service I want to call? Do I need to have some sort of Kubernetes Java library? Do I need to do a REST call to some central server? Or what do I need to do? The answer is on the slide. So what happens is that when Kubernetes runs a container, a pod starts, all these services are injected as environmental variables on that container. So I can just look up an environmental variable using this notation, name of the service _ service host and service port. So I can use that from any programming language. Any developer should be able to look up environmental variables and look it up from Java, Node, script, whatnot, and just take these two. So this is the IP of the service, and this is 8181. That one you should remember. That was the number I chose. The only part that is dynamic is maybe the IP address that Kubernetes assigns to it. So when you want to call, I'm hosting the service. You want to call me? I can tell you already offhand. The service name is hello, and the port number is going to be 8181. The only thing left for the piece of the puzzle is the IP number, and you get it in the environmental level. Now, so what do I need to do in Camel to call that service? In Camel, we made it easy to use environmental variable using squiggly service colon and then the name of the service. So here, instead of localhost 8080, I type service colon hello, squiggly, and that's it. Now, we also talked about DNS naming. It used to be not something you had to add extra to Kubernetes, but now it's baked in. So what we can do now is even simpler. So the name of the service is called hello, and the port number is 8181. So I just type hello colon 8181. Now, if I chose to use 80 as the port number instead of 8181, then I will just type hello without any port number because it's HTTP 80 is the default, right? So now actually I can tell you beforehand, okay, the name of the service hello, the port number is 8181. Okay, cool. You can hard code that in your code application, or you know then what it's going to be. And this is how you can see how it maps to that Kubernetes file. The port number or the name of the service is going to be that up here, and this is the context part. You can add extra. And now we should be able to run that in Kubernetes. So let's quickly do that. And here we can choose either DNS or the Camel version of it. You're free to choose. We can type hello 8181. And just for the fun of it, we want to tell it to disconnect and don't use keep alive. So when we call it the next time, it can do round robin, so it doesn't do session affinity. So that's it. And we should be able to build this code and deploy it to the cluster. So let's do that. So now we have built our source code. We have made it using a Kubernetes service, but how do I take that code and run inside Kubernetes? You use again the Fabricate Maven plugin. It has a goal called run, so it can do everything for you and deploy it on the cluster and run it. So you just type Maven Fabricate :run, and it does that, and you can do that for the client and the server. And of course, I've done it for the server, so let's just do it for the client. Maven Fabricate run. And now it starts to deploy that one. Okay, so while it does that, it should be fairly quickly. We can go over here. So I have a command line up here with the OpenShift command line tool. I can type get nodes to see what I have here on my machine. I have one node called minishift. It's one physical node, so there's only one laptop, right? So I can't have like 2 or 3 nodes. On this node, okay, how many pods are currently running? So it has 5 pods running. There's a Hello Swarm, that is the Hello Service application. Then there's Fabricate Web Console. There's something extra. And then the client is currently being deployed. There's a deployable that's deploying the other guy. And I can type oc get service and find the service. So there is a Hello service. This is the guy we want to use with 8181 and the IP address. So let's go back to see we build and deploy the client application. It says build success, so it should be running in the cluster. And we can use a web console to look at that, which is maybe a bit better. So there's a Fabricate web console that can look at the Kubernetes cluster. And we can look here, for example, on the pods. So here, this is what we just deployed. That is the client. And it's green. And you can look here, that is a button where you can look at the logs. So we look inside, you can see here the client calls, and this is the response from the server. Swarm says hello from, and then the name of the part of the server. So we can look at the logs. And up here we can look at the service, and this is the hello service. There's a link here, I can click that one. I can try it from a web browser also. So let's try to be more fun. We can try to scale up this one. Oh, sorry. Scale up the WildFly Swarm, so now there are 2 instead of only 1. So the second one is going to be scaled up, and then the client should be load balanced between these 2. And let's go and look at that. OCG ports. The screen is to follow the logs of the client. I can type docker ps to look at the Docker process running on the cluster. It need that eval again. So here are the Docker process. Sorry about the screen. I can type docker ps to look at the Docker process running on the cluster. It need that eval again. So here are the Docker process. Sorry about the screen. So what I want to do is to find that one of these swarm. Here up here, this is the second one we deployed. This is the Docker container ID. Now I'm going to be evil and do a Docker kill. So just kill that container. The client is still calling these 2. And let's see if something happens on the client side. Now there's an exception. The client called something, it failed, but it continues calling the other one, and the other one failed. And now after a while it calls. Now they restart and runs again. So why is the client having a failure? There are actually 2 things wrong currently. One thing is we are building distributed applications, so even if a client calls something that is distributed in a cluster, it can still fail. So you need, as a developer, to be aware of that. Also, the second problem is that the WildFly Swarm application is being booted up by the cluster, and there's something in the cluster called readiness. So when a container starts up, is it ready or not? So the idea is that you can have a readiness check where you can tell Kubernetes, okay, when is this guy ready? So while a WildFly Swarm application booting up is only ready at the very end, right, when everything is deployed and HTTP service to okay. But we currently don't have that yet inside Kubernetes. So when you start the WildFly Swarm application, it says ready immediately, even though the WildFly Swarm application is starting to be up. And it takes like 5 seconds or something before it's ready. And when it's ready immediately, then the Kubernetes tells that to the Kubernetes cluster, so the client thinks it can call that one, and they call it too soon. So the solution for that is to implement readiness check inside the WildFly Swarm application, and then it will only say okay when it's really ready, and the client call it at the right time of moment. So you should always have some sort of readiness check in your containers. Now on the other side, it can still fail. The client can still call something that failed for some reason. So you need to build in some sort of redelivery or whatnot, or handle the error. So how can we do that? In Camel, you can use error handling. So we can say on exception, we want to do a redelivery delay of 5 seconds and try up till 10 times or 5 times. So using that code, when something fails in the calling that service, Camel can try again if you want that. Another approach was to use a circuit breaker if you're going to use that. But let's just try this one. And so we go here to the source code and we package, we run it again. So now it will build the source code and deploy it to Kubernetes and update the client. So over here, oops, sorry, this guy. Just wait for this one to finish. So now is to build the client, and this guy should be, now the client should be terminated and start a new client, but there's actually an issue in the current version, so the pod is not restarted. So I'm just going to delete it manually. OC delete. It's going to be fixed in delete pod. So now the pod is dead, and you can see that it's shutting down the logging. So I have to do OC get pause and wait for the new client to start. OC logs follow, so we follow that pod, so we can see the logs. So now the client is starting up again. It's a Spring Boot application with Camel, and starts to call this guy again. Comes here, and it calls one or the other, right? 1 2 1 2. Now Docker PS, we can kill one of these WildFly Swarm ones up here. Docker kill that swarm, so if something happens with the swarm application or one of them. Now we kill it, and the client should not have any errors. It should redeliver itself, and on the same time Kubernetes detected that one of these swarm application servers are down. You told me to have 2, there's only 1, so now I'm going to boot up the second one. But while I boot up the second one, we still have that readiness problem. So while the client called that one, it will still fail until it really is ready, right? But eventually we should see that these two start to call each other again. So we can see the client start to call both of them.
Yay!
Yeah. Okay, so that's awesome, and you can of course have many more than only 2. How much time do we have left?
You have 9 minutes.
Awesome. So just one thing that is fun to see. You can also now this screen is small, but there's a diagram that sort of shows you where the service and the pods and replication controller, how they are linked together. But it's a bit hard to see in this screen. Oh.
Question. Now that you have this many ports and such, are you actually considering what to do with the physical machine when you have no more ports?
Yes, so a good idea is to specify resource limits on your pods. So saying this one needs so much memory, and you can have like a minimum required of memory, and you can have sort of like a desired required of memory, and you can also specify if it's allowed to have like an overcapacity. So you want to have like 1 gigabyte of memory, but it's allowed to burst into 2 gigabyte. So you specify these resource limits, and then you leave it up to the cluster container to figure out where best to stack these parts. And of course, you can always run out of physical memory disk and whatnot, and then the cluster will tell you there's no more limit. So, and that's why you need a racing team to monitor the system, being able to see that now we're running out of resources. So we just add a new physical box to the cluster and register that one, and then the cluster will start to use that as well. And
Specify that for ports, so number of pods running using this many ports, or
so okay, so one, you can also specify, let's say, resource restriction on that. So they try to even out, right? So you don't want to have one node running 200 pods and another one running 2. So there's ways of specifying and have all that kind of things. And you can auto scale, and then you can also have manual scale. So there are quite a lot of flexibility there. Also considering that some of these cloud vendors, they want to have like the best utilization of whatsoever of the resources, and they don't mind things moving around. So sometimes they can stack it over, and they even sometimes run load test and test inside the production system. So if the production system is not busy, why not use it for something else? So that's quite scary, but they're doing that. And it's also like the airlines where they typically overbook the seats on the plane. They do the same on the cloud platform. So you can specify that you have 120% of the CPUs, but because everyone don't use the max CPU all the time. So that's what they're planning with. So that's why they're trying to squeeze out, that's extra. But for regular enterprises, it doesn't matter so much. So the question was, what if you have a database? Will that be part of the cluster or the service or something else? So that's a very good question. So that's a delicate matter. So if you have an existing database, you will leave it out there as existing, and then you can specify an external service to call that database. So from inside the cluster, you can call the database as if you're on the same network. and keep on running the database outside the Kubernetes clusters. Because maybe the database is not ready to run in a container, right? Or it might be Oracle, whatever it is, expensive one you have. But you can also run database inside the cluster. But then you start to have something about the replication of the databases and also about the persistent stores of the database and whatnot. And there are ways of running databases inside a Kubernetes cluster you can do. But typically maybe it depends, So there's no single solution to everything. You should not only do like this. There's different trade-offs. But if you are new to this and start to pick it up, then I suggest go it byte by byte. Don't run everything inside the cluster. You have existing infrastructure outside. That's perfectly fine, and link that to the cluster and start to have a few things running in the cluster. Get more familiar with it, and then start from there. Right? Not a big bang. Yes. So the question was something like, if I'm calling a service that run Docker, and that Docker service fails for some reason, and then the request come back to me with an out of service or some kind of error. Yes, as a client that calls the service, you should be aware of that. But there's a pattern for that. There are some people that working on something they call a sidecar. So to use a extra container co-located with your container, and you call that sidecar. And that sidecar called the service, and that sidecar has implemented redeliver and failover and all that kind of logic. So you, as a client, you don't even to know about that. So there are ways of that. There's something we also discussed of that. So for example, I added some Camel error handler, right? So just imagine you don't even have to do that. So you can sort of maybe customize and specify that more globally, saying, okay, for these service, we allow redeliveries for clients try to gracefully fail and try again and specify some configuration, and then the system automatically figure out that using sidecars. But it works for something and not for everything, right? But just one last thing that is quite a fun. There we have a game in the console called Angry Pods. So you can walk around here, and then the idea is this is a shooting game, and then you and the pods shoot it against each other. If I kill one. So now it doesn't kill them it just simulate killing them, but you can turn that off. The idea is that you should build an application for resilience. So if something dies, it should be okay. There should be some way of failing over and whatnot. And this is a way of just give it a go and kill some of them. And you can specify which pods to include, because some of the pods you may not want to include. For example, there's one called Fabricate Console, which is itself. So you can kill yourself, but you don't actually know it, because this is HTML JavaScript. So it runs in the browser. You run around and kill stuff, and then the web console is died, and you still run, and suddenly, but it takes a while. It's not like, but okay. So just at the end, some slides, and then, there was some guy asked me about how do I actually run this cluster locally on my machine. And you have different ways. Minikube is very good from Kubernetes on the GitHub project, and there's one for OpenShift called Minishift, and we use both of them in our daily work. Today I'm running Minishift, but for the next talk I'm going to use Minikube, trying to switch between them. The old days we have a Vagrant image, you can run it, and then there's OpenShift CDK, which is also possible, but it's more hard to do. With the Minikubes, this is what I did to install Kubernetes and Fabricate. I did download a binary called Go Fabricate, extracted that one, and this is a binary you can run on Mac and Windows and Linux. And I type Go Fabric start Minishift this command line, and it starts up and does everything. And you just type some questions, yes, no. We're gonna make that. There's some enhancement to make that even easier, so you can actually just hit a web link. Or run a script or something like that, but that's a way of starting this up. So this is how I started with 2 GB of memory with only the web console and using Minishift. And let's go to the links. Fabricate website, Fabricate IO. The source code is here. The Minishift guide, Minikube is also good. And we have a community page on Fabricate with links for videos and Docker, a lot of more information. For example, there was a person asking about continuous delivery pipeline and all that kind of things. There are videos about that and a lot more documentation. But I wanted this talk to be, how can I, as a Java developer, get started just on my own laptop, try and run something. And the good thing about Minishift or Minikube is that if something goes fuck, you can just stop it or kill the process, and you can delete the directory where it stores. It stores in your home directory .minikube or Minishift, delete everything, and it's traced, it's gone, and you just start it again. So you're not really fucked.
Thank you very much. It was a really next generation talk. I loved it very much. Great.
Good.